Hello and welcome back to Programming for Data Science. In this part, we shall introduce ourselves to Pandas. My name is Juma Shapara and I'm a data scientist at Raising the Village and the instructor at Data Idea. According to the developers of Pandas, they say Pandas is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built on top of Python programming language. Now that's a mouthful, but basically they are saying you can use pandas for analyzing your data and correcting stuff in your data. Uh, Maybe if there is a problem, you can fix it, and things that are related to what I just said. To go through pandas, we shall use Google Colab. So you can go to colab.google and then you'll land on this site where you can create a new notebook. Now, everything we shall use in this course is available on the website science.dataidea.org. I designed this website myself to host all these materials, okay? And we are using Google Colab, but if you want to install Python and Pandas on your computer and use them locally, there is also a video under the Pandas crash course section. There is a video that guides you through that. You can install Python, create virtual environments, install their Pandas. Okay, you can just dash over there and you install if you want. But you don't have to to follow along. Okay, so here we have our collab, and because we will be following this side, I will just split these tabs, okay, so that we can have them like side by side, you know. Let's have here this. Okay, here is the thing. The first thing we want to do is we want to import pandas. Pandas is a library, so Python library, so we can first of all import it. To be able to use it, we shall import pandas as an alias pd, okay? And we have to do like this to import for reasons that I mentioned in the earlier video, Python for data science. So there is an earlier programming video, Python programming video. You can just go watch the module section of that and you'll find why we do this. But for now, let's just check the Python version, the pandas version. So I can do pd dot underscore underscore version, okay, underscore underscore, and I'll just print this, okay. And let's see, we have 2.2.2 is the version installed for us in Colab. By the way, that's why Colab is really nice. You find all this stuff installed for you, so you just begin to use, okay. Now, the reason why Pandas is very popular is because it has a data structure that is very, very handy. It's called a data frame. This data frame allows us to store data in rows and columns, okay, like Excel, okay. So original data frames like dictionaries and lists don't allow this, so this allows us to do that, and makes analyzing our data really a bit easier, okay. So to create a data frame, there are about three ways. The first way is by using a dictionary, and I'll just copy this code on the website. You can do the same. Okay, so I'll just copy that and I'll rename this one. Instead of data dictionary, I'll rename this to just data one. Okay, it's, keeping it simple so that it fits here. And what do we have here? We have a dictionary having a list of ages, a list of genders, and a list of incomes displayed like this, okay. And to create a data frame from this dictionary, we shall just I'll also rename this one to like data frame one, okay, is gonna be pd dot data frame. Now notice that data frame here is capital D and capital F, okay. So we can run this, and if we print out data one, okay, we can see that we have this 2D structure. Okay, we have a column. The key here, the keys are converted to like column names. Okay, like here, and the lists under them become the values in the under the column. Okay, so the result is we have like age 65, gender male, and income 42 as row one here like this. Okay, so that's how one way to create a data frame. Now the other way to create a data frame is by using a list. So I'll also just copy this, okay, and I will paste it right here. So basically this is a 2D list, and we have some bunch of lists. We have about 5 lists inside another list. That's a 2D list here in this case. And I'll call this one, instead of like data list, I'll rename this one to be data 2. Okay, so I'll just name this one to data 2, and I'll rename this one to be data 2. Okay, now the way we have organized the elements in each of the lists is in such a way that the very first value will represent the age. The second value in each of the lists will be representing the gender, and the third value in each of these lists will be representing the income. Okay, like that. And to create uh, to create a data frame from a 2D list, you will have to specify the column names separately, unlike for the dictionary where the keys were automatically converted to column names. Here we don't have keys of sort, so we have to define our column names separately like this in another list, and then we can do pd.dataFrame, and we pass in the data, and then we also pass in the columns. Okay, so when we run this and we print data2, we shall confirm that this one also creates for us this creates for us this table where we have the age, like this, and the gender also like that, and the income also like that. Okay, this is good. This is really, really good. Now the next part is, sometimes you may want to read existing data. Okay, um so what we'll do is we'll just create a little Excel table, and then we shall try to read that Excel table. So let me just do that. In this section, let me just create a new file. So I'll create like a new file, and here I'll create a CSV file. Okay, so I'll call it like sample data.csv. Okay, and I want to open this one on the side here. Okay, so let me just I want to open this on the side. So there are no entries. Looks like I can't edit my CSV file from Colab, as I don't see that. So let me just create one from Google. So I'll go to docs.google.com, and then we just create one real fast. So let's create sheets. Okay, so in Google Sheets, let's have let's have age, gender, and income. Okay, so let's just do that. Let's have age, let's have gender, and let's have income. Okay, like that. So let's have maybe like 29. Okay, and the gender may be female. Okay, and then the income is maybe 1000. That let that be USD. And then we have like 64, okay, and then gender male, and then their income is like 20,000, 21,000. All right, let's just add one more, and then we call it a day. So let this one be 31 and also male, and let the income be like 22,000, okay, like that. So this is enough. We'll just save this and then have it in Google Colab. So I'll call this one sample data, sample data, okay, like that. And I'll download this. I can download Excel or CSV. Okay, I'll begin with Excel. And yeah, it's downloaded. So let's see what we have here. Okay, I'll just copy this. Maybe instead of copying, let me just upload it right here. So let's open here and let's delete this one that we had created earlier on. Okay, and then we upload our new one. So let's go to downloads and we upload sample data.excel. Okay, so it gives you this little warning when you are uploading. It says ensure your files are saved elsewhere, because these runtime files will be deleted when this runtime is terminated. Basically, when the runtime you set up on Colab is done, your files will be deleted. So just beware. Okay, so yeah, that's it. Let's try reading this one. This is an existing file. Okay, it's called sample data.xlsx. Okay, let's just read that. So we can say data3 is equal to pd dot read excel to read excel files. Okay, and then we can pass in our file, the path to our file, the value for IO, and say it's equal to sample data dot xlsx, like that. Okay, and yeah, let's just run that. And then if we print out, so let me just call this one data3, okay, like that. And if we print data3, okay, we get our data frame that we just created. Okay, these are the values. We have the ages as such, the genders, and the incomes. Okay, like that. So here we have a data frame, basically. Now the first thing, the other trick that I want to show you is how to combine two or more data frames. Okay, if you want to combine two or more data frames, you can use pd.concat. Okay, so I'll just do combined data. Maybe I'll just say data or data, like that, and is equals to pd.concat. Okay, and then concatenate takes in an iterable object. Okay, so we'll say objects are equal to, so it can be a tuple or a list. An iterable object can be a tuple or a list. I would prefer using a tuple, but you can use a list if you like. And so inside the tuple, I'll pass in data1, data2, and data3, like that. Okay, and then I run that. Now if I print data, yeah, we can see that all the data has been combined, okay, to form this one bigger data frame. Okay, really nice. Now before I continue to show you other tricks, if you would like to find some help with anything in Pandas, you can use help. Okay, you can use help. Okay, or you can use this question mark. So let me just show you with help. You can say help and you do pd.concat. Okay, when you run that, it displays basically some documentation about concat. Okay, so help on this function concat, and it does a bunch of things, and here there is the documentation about the parameters, and it returns an object, and there is also more stuff. So you can just, even examples, so you can just read through that. Okay, okay, if you want. So yeah, that is it. Let's just continue, and what I want to show you next is one thing. If we look at the data frame that we just created, okay, let me first remove this because it's just way too long. Okay, it's just way too long. So if we just look at the data frame we just created, we see that we have some numbers at the beginning here. Now these are like indexes, and usually these indexes, they represent rows, and usually you want them to be unique. Okay, but after combining our data frames, we have them um have random like this. Okay, which is probably not advisable. So you may want to go about that by passing here a little parameter called ignore index. Okay, ignore index, and then you set that one to true. So just to be organized, I'll pass this one to the next line. Okay, so that we look just a bit more organized like that. So I'll just run this. And now if I print, yeah, now it's the indexes are really organized. Okay, that's nice. Now let's continue, and we go to the next thing. So the next thing is we will probably be interested in sampling values in a data frame. So if you want to look at the top part of your data set or your data frame, you can just do data dot head. Okay, just say your data frame dot head, and you can print the result. Okay, so maybe I can store this one in a variable, and then I can just set top is equals to that, and if I print the top part, you see it returns automatically the top 5 values. Okay, it turns out that this one also takes in a parameter n, which basically specifies the number of rows you want to be returned from the top. So if I set this one to 3, it will return only the top 3. Naturally, it will return the top 5. If you want to look at the bottom values, okay, you can just do data dot, not bottom, no, tail. So you can do dot tail like that, and then tail also can take in n to specify the number of samples you want from the bottom. And then if we print out, yeah, we get these at the bottom 3 guys. These are the ones we created in Excel. However, also if you would like to just randomly sample values from your data frame, you can do sample.sample. So I'll do samples, and I say data.sample, and also sample takes in a parameter n, which is the number of samples you want to get. And if we display them, you can see that here they've been picked at random. For example, there is 0, there is 5, and then there is 10. Okay, if you don't pass in this n, it will just return one sample. Okay, one sample like that. Okay, so you know what to do. If you want like 5, you will do that. So again, as you can see, they are picked at random somehow. Okay, now the other thing you may want to do is you might just be interested in selecting out only a particular section of our data set. So if you would like to select out maybe a specific value from our data set, like if you want to see this big value. Okay, so let me first display the entire data frame. So I'll print it. Yep, if you just want to pick out this big value here, or you want to see this other value, you can just do data dot, and then you can say iloc, okay, and then you open square brackets, and what you pass in here is two things. One is the row that you will be picking, and here we see row 11, so let's just pass this one here, 11, and then the column. So column is 0 1 2, so that's like column 2. And if I just print out what is returned here, so let's just print this. Yep, we get this big value. Now as I have counted here from 0 1 2, we specified 2, but if you already know like the name of this column, and maybe counting its position is too difficult for you, or maybe for some reason you don't want to do that, you can also do data dot lock, okay, lock, and then you can say 11, and then you can say income, like that. So if we just print this out, okay, we get the same answer. So you just use what you prefer, okay. Now this same technique can be used to change a particular value. Now if we realize that 21,000 is maybe an outlier, okay, and we want to modify it maybe to the maximum value, which is like 2,000 right now that we know, we can do that. So we can set data dot lock, okay, and then we pass in the position, it's index 11, and the column is labeled income, and then we set the value to 1000, like that, okay. If I run this and now I print data, we'll see that the value has been modified to be 1000, okay. So pandas is used for manipulating your data, and it is literal, okay, like that. Now the other thing you may want to discover is there is also iArt and if just art. So these also exist. I'm not gonna discuss them in this video, so you can just read about them from the learning materials, okay. And here you will think about how to rather when to use lock or when to use art, iArt, ilock, okay. So just pass over to the website and then you check that out. Now what I wanted to show you also is how to pick out an entire column. So if you just want to pick out an entire column, you can do, for example, data dot and then the name of the column. Like in this case we can say income if you want to pick all incomes, and we can store this to a variable, maybe say incomes, and then we can print out incomes, okay. This one, as you can see, it's all incomes. You can also just print this one out directly, like you can just do data print data dot incomes dot income rather, so you'll get the same thing. What I just wanted to do is I'll just set to a variable. I prefer this way because it's sort of organized, but you can do what you like. There is another way to get the income, get a column basically. You can do incomes data then you open square brackets. Inside square brackets you can open quotes, and then you can pass in the column name, like that, and when you print out you get the same thing. Now this one is advisable especially when your column may contain your column name may contain special characters or spaces. You want to use these square brackets. However, if it's just one single word and doesn't have any really very special characters, you can use this method. This method is generally safe, okay. It's the one you may want to use so much, but just for me I prefer this, but I know when to use this one. So you can also do what you like, but this is the safest to use to access columns. Okay. You can maybe you may also want to access an entire row. Okay. So to get an entire row, um, let's first see what we have here. Um, okay, if I want to get like this entire row here, like row 12, that entire row, I can do I can do uh, I can do data dot log, and I open square brackets, and inside here I can just pass in the index. Okay, only the index, like that. When I run this, it will return only the values in that row. For example, the age was 31, the gender is male, and the income is 2000. Like that. It's really, really simple. If you want to access a range of rows, you can also do that. For example, I can do 9 to 12, like that. Okay, that accesses all these rows, the bottom rows here, from like 9 to 12. You can access maybe from 9 to 11 if you like. Okay, it's a thing if you want to access a range of rows only. You can use lock. Okay, we are really progressing well. Now the other thing that I wanted to show you is you can rename a particular. You can find, maybe you can filter out your data, where you can check which columns have a particular value. Okay, you can check maybe which columns have incomes greater than 100. I'm gonna leave that on the website. You can go to the website and check out how to do that. Which people, which rows have females. Okay, the examples are on the website. You can just check that out. To continue, I would just like to show you how to drop values from a data frame. So if we have a data frame like this, okay, and we want to maybe drop a column. Okay, if we want to drop like a column, maybe the gender column. Okay, we can just do, we can say a new data, for example, is equals to data dot drop. Okay, we use the drop method, and this one will take in some bunch of things. We shall pass in labels, and these labels can be a list of columns if you want to delete many, if you want to drop many columns. If you want to drop only one, like gender, you can just pass it in as a string like this. Okay, and after doing that, you want to specify that you are removing columns by setting axis to 1. Okay, when you set axis to 1, pandas will know you are trying to delete a column. Otherwise, it will not work. So let's just run that, and then we print new data, and then we see what we have. Okay, now in our new data, as you can see, gender is missing. Okay, if you wanted to drop many columns, you can pass in 2 of them, maybe like gender and income. Okay, and when you run this, you will see that you are only left with age. Okay, so you can use the information the way you like. If you want to delete some rows, for example, if I print and now realize that I am storing the result in a new variable because I don't know how to modify the original one. Okay, So the result of when after dropping, a copy will be created, and these columns will be removed, and that copy will be stored in the new variable here. So let's look at the original one. What we have is data. Okay, if I just print this, we have this in the original one. If I wanted to drop maybe some rows, okay, I wanted to drop maybe row 3 and 8 and 10. There are females there, and maybe I want to remove them. You know, I can do maybe new data is equals to data dot drop, okay, and I will pass in labels as a list. I want to drop 1. I no, I want to drop 3, okay, and then 8, and then 10, okay, like that. And these are rows, so I'll set axis to 0 to mean that they are rows, okay. And if I print the new data, you can see that those rows have been deleted. We don't have 3, okay. We also don't have 8, okay. We also don't have 10, and you can see all the females, they are gone. So this is one way to delete all rows, okay. It's my favorite way. Now there are other ways to drop uh, uh, rows and columns on the website. You can go to the website and check out, but this is sufficient to do the job, okay. As an exercise, I want you to search on how to sort and rank data using pandas, okay. So you can research on that. Maybe let me, I don't know if I should give you the solution. Okay, let me give you the solution. If you have some data, so I'll just print this, and here we have all these, and maybe we want to sort by income, okay. We can do maybe sorted data is equals to data dot sort values, okay. And then inside here you can pass in maybe like by age, okay. And then we can set ascending to false if you want to begin from the large ones to the small ones, or you can set it to true if you want to get the small one to the large one. So I think small to large is what I want for now, so I'll set this one to true, okay. And then when I run, we have sorted the age, we have sorted the data by age, okay. Let's try sorting by income, and then we see what we have. Okay, now you can see we've sorted by income, okay. Now I'll leave you to research on how to rank, okay. Just I mean, you have to do some work. Now we can be able to find some basic information about our data set by using describe. So we can find like basic statistics by using describe. Maybe before we go to that part, let's find some other information about our data frame. So you can do data.info. Okay, this is a method on data frames. And if we, okay, I'll just say data info is equals to that, and if I print the data info, yeah, we see some info about the data. We see like there are 13 entries, and the indexes range between 0 to 12, okay. And we see that the data has a total of 3 columns, and column 0 is age. It has 13 non-null values, and the data type is integer. This other one is gender. It has 13 non-null values, and data type is object. Now in pandas, most of the non-numeric values will be assigned a data type called object, okay. So you know, and we have income, 13 non-null values, and it's also an integer. Okay, and then here we see the memory used, and the data types. We have two integer columns and one object column. Okay, basically that is it. Now, in the next part, I said we can look at some basic statistics by doing data dot describe, like that. Okay, and if we print the basic stats, okay, here we have the basic stats. For example, we have the count. By the way, if you haven't noticed, only numeric values, only statistics for numeric values have been returned. So we have count, there are 13. The mean here is 47, here it's 477. The standard deviation here is 16, here it's, and so on. The 25th, all the percentiles and the maximum values, they are returned there. If you want to return also descriptions for the categorical, you can, for the object type, okay, or categorical rather, you can say basic. Maybe let's just say categorical. Cat statistics, cat stats is equals to data dot describe. Okay, and then inside these brackets you can pass in a method called include, and then you can set it to be object, like this. And then if we run this, you can see that there is only gender as the categorical or the object type. Okay, and there are 13 of them, 13 elements. There is two unique ones, okay, because there is only male and female. And then the majority one, males. Okay, top here is not like for the top value, it's like for the majority. And then the number of times the majority are appearing is 10. Okay, some really quick statistics like that. Okay, this is nice. If you wanted to find only for numeric, you can just say include, um, um, so you can say include, maybe int or number. I think number, let's do number and we see. Yeah, number. If you wanted to see for both, so I'll call this one num stats, and then I'll say all stats, and I said this one is equals to data dot describe. Okay, and then I say include, and then I say all. Okay, and if I print out all stats, we shall see that we have all for both the categorical ones, gender here, as you can see. Where it doesn't apply, they put none. Where it applies, they put some values. Likewise for age and income, where it doesn't apply, like model or top, they put none, and where it applies, they fill. So here you can get for all of them, both numeric and categorical. Okay, so yeah, maybe the other thing that I wanted to show you is you can find the number of elements, the number of rows in your data frame by doing maybe data dot shape. Okay, and let's just print data dot shape. You see there are 3 rows, that rather there are 13 rows and 3 columns. Okay, it's like that. If you're just interested in the number of rows, you can also just do len, like how other data containers are. You can do len data. Okay, and then you can print this one out. Sorry, let's just print this. Okay, you get 13. That's how you get like the number of rows. If you want to see if you want to see all columns, you can also do, let's just say all cols is equals to data dot columns, and when you print that, you will get all the columns that are available in our data frame. That's data dot columns. Okay, it's really simple. Yeah, and that is it for now. What I wanted to maybe get a research on is how to find the individual means for each of the columns, median, cumulative sum, minimum, and maximum for an individual column. Okay. Otherwise, let's call it our beginning to pandas, and in the next section we shall be looking at probably version control with Git. Oh, no, we shall be looking probably at NumPy. So just keep up to date, and then yeah. So thank you. You can go to the website and then you leave a comment for that pandas crash course. Also, you can leave a comment on this video. Of course, you should subscribe and like if you want to be updated, and also, show that this video has relevance. You have to like it and you subscribe. That's when other people will be able to get it. Otherwise, thanks and good luck. See you in the next part. Bye bye.